Good afternoon, everyone. I will be discussing the continuation of our topic, which is also about the overview of total quality tools. Let's start with the histogram. What is histogram? A histogram is a graphical representation of a graph frequency distribution with continuous classes. It is an area diagram and can be defined as a set of rectangles with bases along with the intervals between class boundaries and with areas proportional to frequencies in the corresponding classes. In such representations, all the rectangles are adjacent since the base covers the intervals between class boundaries. The heights of rectangles are proportional to corresponding frequencies of similar classes, and for different classes, the heights will be proportional to corresponding frequency densities. In other words, a histogram is a diagram involving rectangles whose area is proportional to the frequency of a variable and width is equal to the class interval. How to plot histogram? You need to follow these following steps to construct a perfect histogram. Letter A. Begin by marking the class intervals on the x-axis and frequencies on the y-axis. B. The scales for both the axes have to be the same. C. Class intervals need to be exclusive. D. Draw rectangles with bases as class intervals and corresponding frequencies as heights. E. A rectangle is built on each class intervals since the class limits are marked on the horizontal axis and the frequencies are indicated on the vertical axis. F. The height of each rectangle is proportional to the corresponding class frequency if the intervals are equal. G. The area of every individual rectangle is proportional to the corresponding class frequency if the intervals are unequal. When to use histogram? The histogram graph is used under certain conditions. The data should be numerical. A histogram is used to check the shape of the data distribution. It is used to check whether the process changes from one period to another. It is used to determine whether the output is different when it involves two or more processes. It is also used to analyze whether the given process meets the customer requirements. If you guys are wondering what is or are the difference between bar graph and histogram, let me differentiate the two. A histogram is one of the most commonly used graphs to show the frequency distribution. As we know that the frequency distribution defines how often each different value occurs in the dataset. The histogram looks more similar to the bar graph, but there is a difference between them. Histograms visualize quantitative data or numerical data, whereas bar graphs display categorical variables. In most instances, the numerical data in a histogram will be continuous, having infinite values. Attempting to display all possible values of a continuous variable along an axis would be foolish, while bar graph is the graphical representation of graph data in continuous manner. It indicates comparison of discrete variables, while histogram is not. Referring to the space of the graph, bar graph bars do not touch each other. Hence, there are spaces between bars, while histograms bars touch each other. Hence, there are no spaces between bars. Next would be types of histogram. The histogram can be classified into different types based on the frequency distribution of the data. There are different types of histogram, such as uniform histogram, symmetric histogram, bimodal histogram, and last would be probability histogram. Let's start with uniform histogram. A uniform distribution reveals that the number of classes is too small, and each class has the same number of elements. It may involve distribution that has several peaks. Next is symmetric histogram. A symmetric histogram is also called a bell-shaped histogram. When you draw the vertical line down to the center of the histogram, and the two sides are identical in size and shape, the histogram is said to be symmetric. The diagram is perfectly symmetric if the right half portion of the image is similar to the left half. The histograms that are not symmetric are known as skewed. Next is bimodal histogram. If a histogram has two peaks, it is said to be bimodal. Bimodality occurs when the dataset has observation and on two different kinds of individuals or combined group if the centers of the two separate histograms are far enough to the variability in both the datasets. Last is probability histogram. A probability histogram shows a pictorial representation of a discrete probability distribution. It consists of a rectangle centered on every value of x, and the area of each rectangle is proportional to the probability of the corresponding value. The probability histogram diagram is begun by selecting the classes. The probabilities of each outcome are the heights of the bars of the histogram. Next topic is scatter plot or scatter diagram. What is a scatter plot? Scatter plots, also called scatter graphs, are similar to line graphs. A line graph uses a line on an x and y axis to plot a continuous function, while a scatter plot uses dots to represent individual pieces of data. In statistics, these plots are useful to see if two variables are related to each other. For example, a scatter chart can suggest a linear relationship or a straight line. Next would be correlation in scatter plots. The relationship between variables is called correlation. Correlation is just another word for relationship. For example, how much you weigh is related or correlated to how much you eat. There are two types of correlation: positive correlation and negative correlation. If data points make a line from the origin from low x and y values to high x and y values, the data points are positively correlated. If the graph starts off with high y values and continues to low y values, then the graph is negatively correlated. Next is 3D scatter plot. A 3D scatter plot is a scatter plot with three axes. 3D scatter plots are used to plot data points on three axes in the attempt to show the relationship between three variables. Each row in the data table is represented by a marker whose position depends on its values, and the columns set on the x, y, and z axes. Last topic is run charts and control charts. A run chart is the simplest of charts. It is a single line plotting some value over time. A run chart can help you spot upward and downward trends, and it can show you a general picture of a process. A control chart also plots a single line of data over time. A run chart is quite simple in its design and application, and it allows you to visualize the way a single variable or group of variables changes over time. In relation to your operations, there are many applications for a run chart, and it's one of the most flexible tools available for analyzing trends in data, but its simplicity is often mistaken for a lack of utility. A good application of a run chart is identifying cycles or other odd variations in the process. Whenever some deviation from the norm occurs, and it can be traced to a random factor affecting the process externally, a run chart can give you a good idea of the source of the issue and allow you to localize it very efficiently. It's not rare to see run charts used to analyze how the performance of the company has been evolving in relation to the initial expectation about it, and they can indeed visualize this type of relation very effectively. To this end, run charts are also great for showcasing your progress to your customers or someone else who might be interested in finding out where the project currently stands. Next is control chart. A control chart can be seen as an extension of the run chart. It does indeed have many similar characteristics. However, where a run chart is concerned with showing how a process has been evolving through time with no regard to any target parameters, a control chart can give you a good overview of the current situation while taking some limits into account. In other words, using a control chart can help you visualize if a process is staying within its reasonable norms. In cases when it doesn't, the control chart will also show you the exact nature of the scale of the deviation, allowing you to take localized action to correct the issue. A control chart is more useful than a run chart when deviations are important to be accounted for, and when you need to be able to take corrective action as quickly as possible. On the other hand, it can unnecessarily complicate things if that kind of information is not relevant to your current activities. In that case, you should probably use a run chart instead, or at least minimize the number of limits visualized on the control chart. Other differences of a run chart and control chart. A run chart is used to study collected data for trends or patterns over a specific period of time. A run chart will help you monitor data over time to detect trends, shifts, or cycles. Compare a measure before and after the implementation or solution to measure impact. The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a center line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data. That would be all. The remaining topics will be discussed by the next reporter. Thank you for listening.